and also at t equals 3. So we know that the instantaneous velocity is the derivative of x by t. So we will say that v equals dx by dt. So first of all, we will uh, get the derivative of x of this equation. We will differentiate it, and then we will gonna substitute t one time with 1 with 2 and one time with 3. So let's differentiate. I hope you knew some calculus. Okay, 2.0 will be 0, so v equals dx by dt also equals, so 0 plus 3.6t will be derived to be 3.6, and 1.1t will be 2, okay, plus 2.2t. This is the first derivative, and this is v. So we will substitute t one time with 2 and one time with 3. Okay, let me just I'll have to delete most of these so I can free up some space. Yeah, that's much better. Now and get this in here, and let's complete. So at t equals 2, v equals, and when we say v, we means instantaneous. We don't have to say instantaneous, because any v actually is instantaneous, but we need to indicate that v is average when we get the average velocity, saying v av. Okay, v instantaneous equals 3.6 plus 2.2 multiplied by 2 in this case, which will be equal to 3.6 plus 4.4 equals 8 meter per second. And at t equals 3, v equals 3.6 plus 2.2 multiplied by 3 in this case, which will be equal to 3.6 plus 6.6 6 plus 3 equals 9, 6 plus 6 1.2 equals 10.2 meter per second. And that's it. This is the answer of the third question, and actually I was concerned about the last question because instantaneous velocity is will be with us along the trip. So how much time do we have? Okay, let's move forward and talking about the relative velocity, and this is a very easy concept. The relative velocity is the velocity of moving object relative to another one, whether the other one is moving or at rest. So if these two objects are moving in the same direction, so the total the relative velocity will be equal v1 minus v2, because if you were moving beside another car a car is moving with velocity of 100 kilometer and you moving with the velocity of 101, so you'll find that the progress is so slow that as you are moving passing by him with velocity of 1 kilometer only, and this is because the relative velocity of your car uh, with respect to the other car equals v1 minus v2 equals 101 minus 100, so it will be equal to 1. And if these two objects are in the opposite direction, so the relative velocity will be equal to v1 plus v2, because if you were in opposite direction of another train or another object, you will find that it moves very fast, because the relative velocity of this object with respect to you will be equals to v1 v1 plus v2. Okay. And here is another problem. An automobile traveling 95 km per hour overtakes a 1.1 kilometer long train traveling in the same direction on a track parallel to the road. If the train's speed is 75 km per hour, how long does it take the car to pass it? And how far will the car have traveled in this time? Okay. First of all, they are moving with constant speed, and also they're moving in the same direction. So the train is moving with direction of 75 and the car is moving with direction of 95 in the same direction. So the relative velocity of the car is actually 95 minus 75 equals 20. And I think we solved this problem before. Okay, the relative velocity of the car will be 20. Uh, uh, Assuming that this car is at that this train is at rest, so the car will be at 20 km per hour, and we'll find how much time it will take to cover this 1.1 kilometer, right? And of course it will be traveled 1.1 kilometer. Okay. Oh, no, excuse me, this is my fault. Okay, first of all, let's see. In this case, v relative equals v1 minus v2 equals 95 minus 75 equals 20 kilometer per hour. So, and we have delta x equal to 1.1 kilometer, 1.1 kilometer. So we now have delta x and we have v, so we know that v equal to delta x over delta t. So we want to know delta t, so delta t equals delta x b delta x over v equals 1.1 over where's v? Yes, over 20 equal 1.1 over